Welcome to Explore TV, where we uncover the mysteries that time tried to bury. If you're passionate about Earth's hidden wonders, lost history, and the most extreme scientific feats, hit that subscribe button and join our journey to the unexplored. What was found in the Kola Superdeep Borehole? Let's find out together. This water did not naturally evaporate at any depth in the borehole. The drilling mud that flowed from the hole was noted to be boiling with an unexpected amount of hydrogen gas. Microscopic fossils of plankton were located 6 kilometres (3.7 miles) below the surface. Why can't we dig deeper into the Earth? As depth increases within the Earth, both temperature and pressure intensify. The temperature in the crust rises by roughly 15 degrees Celsius for each kilometre, making it impossible for humans to survive at depths greater than several kilometres, even if it were somehow feasible to keep shafts open in the face of the overwhelming pressure. Beneath the icy crust of the Russian Arctic, a chilling wind sweeps across a desolate landscape. Hidden beneath abandoned buildings lies a scar in the earth, not a mine or a cave, but something else entirely. The Kola Superdeep Borehole, once the deepest man-made point on Earth. Born from Cold War rivalry, it was a monument to scientific ambition. Now sealed and abandoned, its story remains a testament to humanity's urge to explore the unknown. The Kola Superdeep Borehole was a bold Soviet quest to drill deeper into the Earth than ever before. Launched in the 1970s, it became the flagship of a program to unlock the planet's ancient secrets. For decades, scientists battled extreme pressures and heat, uncovering mysteries no one expected. The journey downward shattered scientific theories, revealing a world beneath our feet still full of surprises. In the 1960s, as the US and USSR raced to the moon, the Soviets quietly launched a different quest, drilling deep into the Earth's crust. This was their own space race, an audacious journey inward, seeking to unlock the planet's secrets. While the world watched rockets soar, Soviet scientists battled gravity and heat, drilling deeper than anyone before. It was a bold symbol of national pride and scientific ambition, exploring the unknown not above but below. In the late 1960s, the Soviet Union launched an unprecedented scientific program, a nationwide network of super-deep boreholes to explore the Earth's crust. The goal was to map deep geological structures, solve ancient puzzles, and push the limits of drilling technology. Presented as a symbol of Soviet innovation, this project aimed to reveal the mysteries beneath our feet. The Soviet super-deep drilling program was unique. Its goal was pure science, not profit. Scientists chose the Kola Peninsula for its ancient rocks, not for oil or minerals. The region's exposed crust offered a rare glimpse into Earth's deep past. Their treasure wasn't oil but knowledge, data from the depths for science alone. The Kola Peninsula, a remote finger of land in Russia's far northwest, was chosen for its ancient stable rocks, part of the Baltic Shield, Earth's oldest foundation. Here, scientists weren't just drilling into the ground, they were drilling back in time, seeking secrets from when life on Earth began. Amidst the frozen tundra, the quest to unlock our planet's ancient history began. The Kola Peninsula's unique geology gave the Soviets a head start. Millennia of glacial erosion had stripped away younger rocks, exposing ancient crystalline basement rock right at the surface. This meant the team could immediately drill into 2.5 billion-year-old formations, skipping years of work. Most places on Earth bury these rocks deep under layers of sediment, but here the shield was exposed and stable, perfect for deep drilling. The region's tectonic calm meant fewer risks from earthquakes or volcanic activity. The Kola site offered a rare direct path to the ancient crust, making it a geologist's dream. The stage was set for a journey into Earth's oldest secrets. The Kola project aimed to test a core theory in geology, the Conrad discontinuity, a supposed boundary between granite and basalt deep in the crust. Seismic data hinted at this layer, but no one had ever seen it. The Kola borehole was the first chance to drill through and find out if it really existed. Here, erosion had brought the boundary closer to the surface, making it accessible. Every meter drilled was a step toward confirming or overturning a foundational idea about Earth's structure. The Kola team wasn't just drilling deep. They were drilling smart, targeting a mystery at the heart of geology. The site was chosen with precision, maximizing the chance for a scientific breakthrough. Drilling began in May 1970, marking a new era in Earth exploration. The Ural Marsh rigs weren't just machines, they were scientific laboratories, designed for precision and data collection. Instead of spinning the entire drill string, engineers used a turbo drill at the bottom, powered by high-pressure mud, allowing for deeper, more controlled drilling. Progress was slow but steady, with the team retrieving pristine core samples from ancient rocks. By 1979, Kola had become the world's deepest borehole, a triumph for Soviet science. But as the drill went deeper, the rock grew denser and the borehole harder to control. The team faced constant technical challenges, from bent drill strings to unpredictable geology. Each meter gained was a victory against the unknown as the team worked around the clock in one of Earth's harshest environments. The journey downward was just beginning. Past 7 kilometers, the Kola team's expectations unraveled. The Conrad discontinuity, missing. Instead of basalt, they found only altered granite, forcing a rewrite of geology textbooks. Even more shocking, water, deep in the crust, squeezed from the rocks themselves, not from the surface. Then came microfossils, ancient plankton, preserved in billion-year-old rocks far deeper than anyone thought possible. Free hydrogen gas bubbled up, hinting at unknown chemical processes. Each core sample revealed a dynamic, living Earth, not the inert crust scientists had imagined. The Kola borehole became a window into a world of surprises. Every new depth brought more questions than answers. The greatest challenge wasn't rock or depth, it was heat. Scientists expected 100 degrees Celsius at 12 kilometers, but found 180 degrees Celsius, far beyond their equipment's limits. The rock softened, boreholes warped, and drill strings snapped, leaving expensive gear lost underground. Each setback forced the team to start new branches, slowing progress to a crawl. By 1989, they reached 12,262 meters, a world record. But the dream of 15,000 meters was crushed by the relentless heat. No technology could survive the projected 300 degrees Celsius at greater depths. The Kola project hit a physical wall, the Earth itself pushing back. Humanity's deepest journey ended just short of its goal. The discovery of microfossils deep in the crust changed everything. These ancient plankton, preserved in billion-year-old rocks, proved that life's chemical traces reach far below the surface. The deep crust, once thought sterile, became a potential reservoir for life's building blocks. The find hinted at a hidden biosphere, microbes thriving miles underground, living off rock chemistry, not sunlight. Kola's data inspired new searches for life in extreme environments, on Earth and beyond. If life's traces survive here, could they exist on Mars or other worlds? The Kola borehole, meant to study geology, opened a new frontier in the search for life in the universe. As the Kola Superdeep Borehole reached record depths, a chilling legend spread: the well to hell. The story claimed Soviet scientists drilled into the underworld, capturing the screams of the damned. Though entirely fabricated, the myth went viral, blending science with our deepest fears of what lies beneath. The myth of the well to hell was fueled by a chilling audio recording, grainy, distorted, and filled with unsettling screams. But experts traced its origins to B-movie sound effects, debunking the legend as a clever hoax. Still, the Kola Superdeep Borehole remains a symbol of our curiosity, where science ends and myth begins. The well to hell was fiction, but the Kola Superdeep Borehole's real discoveries were just as revolutionary. Instead of hellfire, scientists found extreme heat, 180 degrees Celsius at 12 kilometers, reshaping our understanding of Earth's crust. They also discovered water and hydrogen gas deep below, revealing complex, mysterious processes still not fully understood. The Kola borehole stands as a monument to human curiosity, pushing the boundaries of science, not myth. The Kola Superdeep Borehole, once a hub of Soviet science, now lies abandoned and sealed beneath a bolted metal cap, almost invisible in the Arctic decay. Yet its legacy endures as a monument to human curiosity and ambition, a reminder that the greatest mysteries may lie beneath our feet. The Kola borehole stands not for resource extraction but for the quest for knowledge, a symbol that continues to inspire new generations. The most significant and enduring legacy of the Kola Superdeep Borehole is not the hole itself, but the priceless data extracted from its depths. For over 2 decades, the project generated a treasure trove of geological information that fundamentally altered our understanding of the Earth's crust. Before Kola, our models of deep geology were based almost entirely on indirect evidence, primarily from seismic waves. The Kola borehole provided the first ever ground truth, allowing scientists to compare their theories directly with physical reality. In many cases, reality proved to be far stranger and more wonderful than the theories had predicted. The discovery of water deep within the crystalline basement rock was revolutionary. It completely overturned the long-held belief that the deep crust was dry, demonstrating that water could be locked within the rock structure itself and released under immense pressure. Similarly, the absence of the predicted basalt layer at the Conrad discontinuity forced a complete revision of the standard 2-layer model of continental crust. These findings, published in countless scientific papers, sent ripples through the geological community, compelling a re-evaluation of the fundamental processes that govern the formation and evolution of the continents we live on. Beyond these major discoveries, the Kola data provided a wealth of detailed information. The continuous core samples, meticulously logged and preserved, represent a unique library of Earth's history written in stone. They allow scientists to study the fine-scale changes in rock chemistry, mineralogy, and physical properties over a 12-kilometer vertical section. The temperature data, which showed a much hotter gradient than expected, improved our models of heat flow within the planet. Even the discovery of hydrogen gas offered new insights into deep Earth chemical reactions, a field that remains active in research today. This massive dataset continues to be a valuable resource for researchers around the world. The core samples are still stored and studied, yielding new insights as analytical technologies improve. The Kola Superdeep Borehole was, in essence, a giant, Earth-sized laboratory experiment. It provided the raw material for decades of scientific inquiry and laid the groundwork for future deep Earth drilling projects. Its impact is written directly into the pages of modern geology textbooks, ensuring that the work of the scientists on that remote Arctic peninsula will not be forgotten. The project's scientific legacy is as deep as the hole they drilled. The formal halt of the Kola project in the early 2000s, due to a combination of insurmountable technical challenges and the withdrawal of state funding after the Soviet Union's dissolution, left the mission tantalizingly incomplete. The team had hoped to reach a depth of 15,000 meters, a goal that remained just out of reach. The primary barrier was the extreme heat, which soared far beyond what their technology could withstand. This heat barrier represents a fundamental frontier, a physical limit that continues to challenge scientists and engineers who dream of probing deeper into our planet. The questions that the Kola borehole raised are in many ways as important as the ones it answered. The unexpected presence of water, microfossils, and hydrogen gas opened up new avenues of research that are still being explored. What other chemical and biological processes are occurring in the deep crust? How far down does the deep biosphere extend? What is the true nature of the boundary between the crust and the mantle? The Mohorovičić discontinuity, which lay just beyond Kola's ultimate reach. The project ended not because the science was finished, but because the technology and funding had reached their limits. The legacy of Kola, therefore, includes a call to action for future generations. It highlighted the immense scientific rewards that await those who can overcome the engineering hurdles of deep Earth exploration. It has inspired subsequent projects and proposals such as the International Ocean Discovery Program, which drills into the thinner oceanic crust, and ambitious plans for drills that can penetrate magma or survive the intense conditions of the upper mantle. The Kola project proved that the journey is possible, while simultaneously defining the technological chasms that must still be crossed. The story of the Kola Superdeep Borehole is ultimately one of both triumph and incompletion. It is a tale of reaching deeper than ever before, only to find that the heart of our planet guards its secrets with a fierce, fiery intensity. It pushed the boundaries of human knowledge to a new, incredible depth, yet it left the final chapters of the story unwritten. This unfinished journey serves as a permanent challenge, a deep, dark and silent invitation for future explorers to pick up where the pioneers of Kola left off and continue the audacious quest to understand the Earth from the inside out. The Kola Superdeep Borehole wasn't just a hole in the ground. It was a gateway to knowledge, to mystery, to the core of human curiosity. And here at Explore TV, we believe every mystery deserves to be explored. So if you're fascinated by Earth's secrets, ancient history, and the hidden stories science reveals, subscribe now and be part of a growing community that dares to dig deeper. Until next time, keep exploring.